All right, so we have this. In our example 2, we have an investor has 10,000 Ghana cedis to invest, to undertake a project. He has been presented with 2 possible projects and their expected cash inflows. Assuming that the rate of return is 15%, calculate the net present value for the project and decide on which one to invest in. It's very, very simple. So you see here, we have the years 1 to 5, then we have the expected cash inflow for project A, and then the expected cash inflow for project B, assuming we have 10,000 Ghana cedis in hand. So we are going to decide on which of these projects to undertake. Remember, the rule states that go for the project that offers you a higher net present value, or go for if they are all offering you the same value, the same number or something, and then you find out that one is positive, one is negative, you go in for the positive one. So how do we do this? We can solve this one in 2 methods, just like the first one that we did. We can equally use a table method, or we just go by the process we used for our previous example. So let's say I want to do this method 1. Remember, our net present value is equal to our present value minus cost of investment. That is the initial cash outlay. Very, very simple. So remember, we are working for net present value for project A. So our present value can be written as our future value 1 plus r raised to the power n, that is 1. Future value 2, 1 plus r raised to the power another n. So you can equally write the numbers here, 2, 1. Then 1 plus r raised to the power 3. Future value 1 plus r raised to the power 4. Future value 1 plus r raised to the power 5. Assuming there is a scrap value. Scrap value is maybe we are selling it at the end of the feed period, depending on the question. Assuming in our question, I'm going to say, if at the end of the feed year we decide to sell one project B, that is project A, the scrap value is 20,000. You add the 20,000 to this. So can year 3, year 3 now. You add that 20,000 to year 3. But since there's nothing like scrap value, we just go by the normal approach. All right. So we have number 1. What is the future value for year 1? 2,500. All over 1 plus our rate of investment is 15%. And 15% means 15 over 100. You see 1, 2, 1, 2, meaning 0.1 5. So we have 0.15. Someone will say 1 plus 0.15 is just 1.15. So instead of writing all of this, we can equally write 1.1 raise the power 1. Then, unlike the first one we solved, where they said there was an equal cash inflow. Here you see that there's variations in the cash inflows. We have year 2, we are expecting a return of 2,000. So 1, that's our discount factor. Have it in mind. In our previous lesson, we treated how to calculate a discount factor. All right, so we are going to use that when we get to method 2. Then year 3, we have 1875, 1.15 raised to the power 3. Year 4, we have this 1.15 raised to the power 4. Then here we have 3,000, 1.15 raised to the power 5, in that order. So let's put everything in our calculator. So we have 2, 5. So we put all of this in our calculator and we have 7,125.27. So meaning therefore our net present value for project A is going to be our present value minus cost. So our present value is 7,125.27 minus the cost. And what is the cost? 10,000. So 10,000. What do we have here? We have 7125.27 minus 10,000. That will give us negative 2874.73. But in accounting and finance, we don't normally write negative. So negative value means you put them in a bracket. You put them in a bracket, meaning it's a negative what? Value. So that is our net present value. Now, let's do same calculation for project B. So under project B, we are using the same formula. So we have our present value. That is we have our future value as this, 1.15 raised to the power 1. Then we have 3750, 1.15 raised to the power 2. Then we have 2,500, 1.15. We have 2250, 1.15. Then we have 2250, 1.15 raised to the power 5. So let's compute all of this in our calculator. We have 10,145.29. So therefore, our net present value for project B, as we all know, is our present value minus cost. And what is our present value? We have this. And then what is the cost of the investment, which is our what? 10,000. So minus 10,000, we have 145.29. All right. So you see, looking at these figures, one is negative, one is positive. So the question states that which one should we decide on? So we say since project A has a negative net present value, while project B has a positive net present value, the investor should invest in project B, because he said invest in the one that is offering you a positive net present value. Okay, now with the same question, let's look at method 2.